Welcome to Unstuck. Today, bubble sort, the first sorting algorithm everyone learns. We'll watch it work pass by pass, add the one optimization that makes it useful, and be honest about when you should never use it. From scratch, in Rust, beginner friendly. Bubble sort has a simple idea: walk the array, and whenever two neighbors are in the wrong order, swap them. Do that enough times and the array is sorted. Let's actually watch it happen. If you're just starting with algorithms, this is the perfect first shortcut, and really helps the channel. Here's the idea. The mechanics. Compare each pair of neighbors. If the left one is bigger, swap. By the end of one full pass, the biggest value has bubbled all the way to the end. That's where the name comes from. Then repeat for the rest. Here's the roast, an outer loop of passes, an inner loop of neighbor comparisons with swap when we print the array after every pass so we can see the bubbling. Note the inner loop gets shorter each pass, the end of the array is already sorted. Run it on 5, 1, 4, 2, 8. After pass 1, the 5 has bubbled up and everything shifted. After pass 2, sorted. Pass 3 makes 0 swaps, so we stop early. Watch that last line. No swaps means done. That early exit is the one optimization bubble sort has. Track whether a pass made any swaps. If it didn't, the array is sorted and you stop. Without the flag, bubble sort always does the full n squared work, even on sorted data. With it, already sorted input takes a single pass. Now the honest numbers on 30,000 items. Reverse sorted, the worst case, almost 400 milliseconds. Already sorted with the early exit, 25 microseconds. And Rust's built-in sort on the same worst case, 19 microseconds. Read that again. The standard library sorts the worst case faster than bubble sort handles its best case. That's the honest verdict. Bubble sort's n squared makes it 20,000 times slower on real unsorted data. So when is bubble sorted? For learning, it teaches you passes, swaps, and loop invariants better than any other sort. For tiny arrays where nothing matters. And it's one pass, no swaps check is a neat way to test if data is already sorted. For everything else, use your language's built-in sort, seriously. The scorecard: O often squared worse than average, O often best case with the flag, constant extra space since it swaps in place and it's stable. The equal elements keep their original order. That stability is genuinely nice, the speed is not. Trace the first pass by hand. 5 and 1, swap. 5 and 4, swap. 5 and 2, swap. 5 and 8, no swap. See how the 5 bubbled rightward until it hits something bigger. Every pass pushes the biggest remaining value home. Common mistakes. Now, forgetting the early exit flag, so sorted input still costs n squared. Not shrinking the inner loop by the pass count, which wastes comparisons on the already sorted tail, and the classic off by 1 that walks past the end of the array. Rust will panic instead of corrupting memory, but it will still panic. Recap. Bubble sort swaps wrong order neighbors pass by pass, the early exit flag makes sorted input linear, and everything else is n squared. A great teacher, a poor production tool. Now you know exactly why. Quick one, if this helped you, the wallet's on screen and there's a Ko-fi link in the description. Every tip funds the next one. The full Rust code is in the description. If this helped, hit like and subscribe. A new coding challenge every day. See you in the next one.